Hello everybody, today I'm gonna talk a little bit about how we can use a supercomputer to study coastal disasters in the Gulf of Mexico. My name is George Xue and I'm an associate professor in the Department of Oceanography and Coastal Science at LSU. I also hold a joint appointment with Center for Computation and Technology. I want to address that we have a federal agency and state agency to support my research. So what is a supercomputer? A supercomputer is a computer with a high level of performance. Sometimes you might heard the word called HPC or high performance computing, which refers to the practice of a lot of computing powers in a way that can deliver much higher performance. So this complicated computational task cannot be done on your laptop or a desktop, can only be done on a supercomputer. And this kind of computing, we call it high performance computing. So over the past decade, the development of supercomputer is really fast. So you can see that the performance of supercomputer is commonly measured by floating points operations per second, or we call flops. And you can see from 1993 to 2017, the supercomputer powers, or the flops, has increased from much less than 1 trillion to all the way more than 10,000 trillion. And an interesting fact is that the smartphone you are using now will be millions of times powerful than all the NASA's computers combined back in 1969. We have very good supercomputing facilities at LSU. And in Freehall, we have supercomputers SuperMIC 2, SuperMIC, QuinnB2, and QuinnB3, for example. And on each of these supercomputers, we usually have somewhere around 10,000 of cores. So think about your laptop, you already have like 2 cores or maybe like 4 cores maximum. But on each of the supercomputer, we could have like up to 10,000 cores. So we can use supercomputer to simulate hurricanes, of course. So for example, I'm showing here, this is a simulation for Hurricane Gustav in 2008. And what I'm showing here, the color map is sea level pressure. And we all know that hurricane is a low pressure system. So you can see the movement of this low pressure system as shown in blue color. And the simulated track, which is in blue color, agreed very well with the pink track, which is the observation. The next example is dead zone, okay, or we can call it hypoxia. So this phenomena happens almost every summer on Louisiana, Texas shelf. So it refers to a very low oxygen condition where the oxygen level is less than 2 milligrams per liter. And in this case, we are showing a computer simulation of the bottom oxygen condition in July of 2019. Whenever you see this reddish color, it means that we are experiencing a hypoxic condition, which is definitely no good for fish and benthic ecology. We can also use supercomputer to study oil spill. So in this case, I'm showing a simulation relevant to the 2010 Deepwater Horizon oil spill. And we performed a computer simulation of particles. These particles has been released by supercomputer at the water depth of 1,100 meters. And you can see that the simulation shows that the majority of the particles or the oil will be confined in the central Gulf of Mexico. But we do see some very limited amount of oil being transported all the way to the East Coast. So today I briefly talk about supercomputer and how we can apply them in oil spill, hurricane, and the dead zone study. If you have any question, you are more than welcome to email me at zxue@lsu.edu. Thank you and have a good day.